Hello and welcome to Compound Growth or Loss, Part 1. What this section is all about is we're looking at a specific exponential function or family of functions which are very, very important. They're so important, in fact, that we kind of provide you with a prototype function that I'm going to talk about right now. So A equals P times 1 plus or minus I. Don't worry, I'm going to explain all these little letters here in a second, raised to the n. Now this is kind of our prototype formula, which, by the way, you must memorize. Now let me explain the bits and pieces. This P here is kind of like your starting population or starting amount. Okay, so this is your starting, the reason it's P is because it's like usually a population, but I like starting amount. A over here is the final amount that you end up with. Okay. In here, in the brackets, we have a 1 plus. Now, it's plus if it's growth. If your population increases, then it's growth. But if you lose, like say your population was going down by a certain percentage each year, then we're talking about a loss. And then we'd use the minus. This I in here is the percentage of growth or loss. And it has to be in decimal form. I'll be doing examples here in just a second. So in decimal form. And then n, your exponent, is the number of times that growth has occurred. Sort of number of growth periods. It's kind of the best way to think of this. Okay, and so I'll explain it here with an example. You kind of see all these bits and pieces. If I make sense of them in a certain way. So why don't we do that example and show you how I'm going to apply this formula here. So say you have a present population of 1,200. So a population of 1,200 could be people in a little town or something. And then we're told that this population grows by 7% each year. All right, so we're given that information, and then somebody says, I wonder what the population would be in 20 years. So we're going to predict the population in 20 years. All right. So really, it's using this formula because this is what we call exponential growth. So we start off with, we would like to predict what A is. That's the final amount or the final population. So we don't know it. That's what we're going to try to figure out. The starting amount is 1,200. That's our population at the start. So we're going to go 1,200 times. And now in brackets, we're going to go 1 plus. Now it's plus because it's growth. The population is growing. And it's growing by 7%. Now 7% in decimal form is 0.07. Okay, just think of 7%, which means 7 over 100. So this is like 7 over 100. And then I got to raise it to the number of growth periods. Well, it grows by 7% each year. And we're asking what's population in 20 years. So it has gone through 20 growth periods. Okay? Each growth period happens to be 1 year. And now it's just, once you set this up, it's just a matter of you get your calculator and you plug it all in. And you can pretty much plug it in as you see it, especially if you're clever about using brackets. So we just go ahead and we plug it in, and you should get 4,643 and then some decimals here. Usually we go to 2 decimal places, so 0.62. So that's my, more or less, my predicted population in 20 years. All right, so I'm going to do another example, and again, it's using this formula. But sometimes this formula, we don't have a percentage of growth or loss. We have a different situation. So that's what I'm going to do in this next example. So here, what we have is we have a bunch of ants. In fact, we have 700 ants in an ant nest. And then somebody says it doubles every 5 weeks. Every 5 weeks. All right. Now we want to predict after 18 weeks. So we're going to predict the number of ants, predict the number of ants in 18 weeks. Okay, so this one's got a few twists and turns in it. How do we do it? Well, again, we're trying to get the final amount, which we don't know. We have the starting quantity. That's pretty easy, 700. Multiply that by, wow, what do we put in the brackets now? It's not growing by a percentage. Instead, it says it's doubling. In a way, it's almost easier, because all you do if it's doubling is you put in a 2. You don't mess around with 1 plus some percentage. You just say, yeah, it's always going to double. If it was a tripling question, I'd put in a 3. Okay? So in a way, it makes it a little bit easier. The tricky part of this is, what do you put as the exponent? And this is where you have to think, well, how many growth periods did it go through? Every 5 weeks. Okay, so in the first 5 weeks, it actually went through. So here's the first 5 weeks. That would count as 1 growth period. Then if I did another 5 weeks, so 10 weeks into it, that would actually count as 2 growth periods. Then another 5 weeks, so 15 weeks in total, that should actually count as 3 growth periods. And then we didn't quite make it through to 4 growth periods. So how am I figuring out the number of growth periods from the number of weeks? Well, if you look at 15 and it becomes a 3, or 10 becomes a 2, it seems I take the number of weeks, so in this case 18 weeks, and to get the correct amount of growth periods, I think what I'm doing is just going 18 divided by 5. And that's giving me the correct number of growth periods. So up here, my exponent, and you can either make it a decimal or be sure to put brackets around it when you do it on the calculator, is 18 divided by 5. That's how many growth periods it went through. Well, guess what? The thinking part of this is done. All I have to do now is punch this through on the calculator, and hopefully you don't hit the wrong buttons. So I got 8,488 and 0.01 of an ant. So that's the predicted number of ants in 18 weeks. And that's where I'm going to stop for now, and we'll continue on with this later on.